So welcome, and next I'm going to be making a tutorial for my Algebra 2 class on how to use a graphing calculator to find the intersection between two linear linear equations. You could do this with a quadratic equation and a linear equation as well.
So we're looking at problem 37, 6x minus 4y equals negative 4, and 3x plus 2y equals negative 4. So first we want to change to slope-intercept form. I apologize in advance if you find my handwriting messy, but I'm going to take that first piece right here and change it into slope-intercept form. Divide both sides by 2 to make it a little easier. Subtract 3x from both sides right here, and then down here divide everything by negative 2, leaving me with y equals 1 plus 3 over 2x. Or you could change it to 3 over 2x plus 1 or 1.5x plus 1. Next, take the second one, put it into slope-intercept form, as that is what we want to do for our calculator. Start with 3x plus 2y equals negative 4. Subtract 3x from both sides. I divided both sides by 2 to isolate the y, leaving me with y equals negative 3 over 2x minus 2, or negative 1.5x minus 2. So these two equations I'm going to put into my calculator. So we're going to come over here. So if you can, I'd recommend this in the future. If you can, I would put it into a decimal form, as I think it's a little bit easier to enter in. So what I would want to do in this case, if all you have is a fraction, is I would put first off for when you're negative. So I'm going to do that first one, negative 3x at negative 3 over 2x minus 2. So negative, and then I'm going to put parentheses. So this is the parentheses button. Can't really tell, it's worn off. And then I'm going to put 3 divided by, where is it? 2. And then I'm going to put another parentheses. And then I'm going to put an x, so this is the xt theta n button. And then I'm going to put, let's see, it is minus 2, so I'm going to put minus 2. All right, now I have that first one in. Next, I'm going to put in y equals 3 over 2x plus 1. So I'm just going to, the other way you could do this is 1.5 x plus 1. So now I'm going to go over to graph. I forget where those 4 points are coming from. It looks like I have a pretty solid graph here, but in case the graph doesn't show up on it, you can go to zoom like we did in the other tutorial. If you go, so what I just did is I hit the up arrow to go all the way to the bottom, zoom fit, and that should, it looks like it's just gonna leave me, oh no, it's gonna change it. So in any case, you should have a graph that shows both of the lines pretty close to the intersection. So if I wanted it to do the work for me, I could go over to trace, or my apologies, second trace, so calc. And I'm going to go to, you guessed it, intersect. Now, I'm not really sure what the first curve, second curve are, so I'm just going to hit enter. And then guess. I guess you might want to put your cursor up closer to where it looks like the intersection is. But for now, I'm just going to hit enter. And it says x equals negative 1, y equals negative 0.5. So let's just test that out. So x equals negative 1, y equals negative, I'm going to put 1 over 2. I imagine that will be a little bit easier to work with on the paper. Maybe decimals would be better in calculator. So I'm going to test it out. So y equals negative 3 over 2. And I'm going to put in a negative 1 for here, negative 2 there. I'm going to switch that back. I'm going to put in a negative 1/2 here. So let's just double check, make sure that it works. So we got positive 3 over 2 minus 2 equals negative 1/2. This would be the same as 4 over 2. So if I subtract 4 over 2, I should end up with negative 1/2 equals negative 1/2. All right, that one works. And our second equation is, let's see, y equals 3 over 2x plus 1. So our y is going to be negative 1/2 equals 3 over 2, negative 1 for x, plus 1. So this is going to change to negative 3 over 2 plus, and I'm just going to go ahead and switch over the 1 to a 2 over 2. So they have like denominators, equals negative 1/2. Again, right here, negative 3 plus 2 is going to be negative 1 over 2 equals negative 1/2. Check. So we know that that's
So there you have it. That was the tutorial for how to use your graphing calculator to take two equations, put them into the y equals part of your calculator, graph the two of them so that you can see what it looks like, and then use the trace or calc function to use the calculator to find where the intersection is. So if you're, in this case, if you're ever given, this was two problems in standard form, and then you'd have to put it into slope-intercept form. So if you want to graph something on the calculator and use those functions, you're going to need to put them into slope-intercept form. So for the y equals, if you think about it, slope-intercept form is y equals mx plus b, or if it's a quadratic equation, y equals ax squared plus bx plus c. You're going to need to put it into y equals in whatever case. So it needs to be y isolated anytime before you put it in the calculator. Hope this was useful. Put comments and questions. I should be able to answer them the next couple days. And in the future, feel free to ask me if you would like other follow-up videos for problems. If there's questions on the summer packet, I can also put tutorials for other things so you can study over the weekend. Hope this is useful. Thank you for watching. Stay weird.